All right, let's take a look at an application of a rational inequality. So an economist for a sporting goods company estimates the revenue and cost function for the production of a new snowboard. These functions are r of x is equal to negative x squared plus 10x. So that's your revenue function, and your cost function c of x is equal to 4x plus 5, respectively, where x is the number of snowboards produced in thousands. The average profit is defined by the function a p of x is equal to p of x divided by x, where p of x is the profit function. Determine the production levels that make a p of x greater than 0, and we know profit is the total revenue minus cost. Okay, so our revenue function here is equal to negative x squared plus 10x. Our cost function, so revenue is basically the amount of income that's generated by selling X number of goods at a certain unit price, right? We can call it the unit price, the demand function, or the price function. And the cost function here is the cost of producing X number of goods, or X number, in this case, snowboards, right? So the cost, and remember that this is going to be snowboards that's produced in thousands. So X is snowboards either sold in thousands or produced in thousands. And in this case, we have the cost function is 4x plus 5. So the profit function is the revenue function r of x minus the cost function c of x. And in this case, our profit function here is negative x squared plus 10x minus the cost function 4x plus 5. So the profit function p of x is negative x squared plus 10x minus 4x minus 5, which is basically negative x squared plus 6x minus 5. Okay, so this is your profit function, p of x. And now what we want to figure out here is our average profit function. So they're saying that our average profit function, a p of x, is a profit function divided by x, number of goods in thousands, right? So in this case, we basically have a p of x is equal to negative x squared plus 6x minus 5 over x. And we want to figure out when is our average profit function going to be greater than 0. So when is production going to allow for our average profit to be greater than 0, right? So we want to let ap of x be greater than 0. So we're basically solving for an inequality, right? So we're solving for when negative x squared plus 6x minus 5 over x is greater than 0. And to do this, I'm going to simplify the numerator. So I'm going to factor out the numerator, right? So two numbers that add up to, that will multiply to positive 5, that add up to positive 6, right? So you can do positive 5 and positive 1, right? So in this case, let's do negative x squared plus 5x plus x minus 5. I'm just looking at the numerator, so negative x minus 5 plus 1, x minus 5. So you get 1 minus x times x minus 5. And then this is going to be over x is greater than 0. So this is the average profit function in a simplified form that I'm going to be looking at, right? Now, to solve for this inequality, we need to find critical numbers. So our critical numbers are going to be values of x that include x-intercepts as well as vertical asymptotes. Critical numbers are useful because they can help us to find our particular intervals that we're going to be testing, right? So looking at our x-intercepts, x can be equal to 1 or 5, and our vertical asymptote, x is equal to 0. So I'm going to test all of these intervals, right? We can't have negative numbers of snowboards being created. That makes no sense. So after you find your critical numbers, you want to figure out your intervals. You know what? Let's just move that down a little bit. You want to figure out your intervals. What I'm going to do is I'm going to plot this down. Okay, so we're going to start here, right? We can't have negative number of goods, so let's just put this as a flat line. Okay, so this is 0, right? And this is one of our points. And we also have 1, right? We also have 5, right? And this is positive infinity. This is greater than 5. Okay, so these are some of our points that we want to test out. So one of the intervals in question that we will be assessing here is going to be x is going to belong to, this interval here is 0 and 1. So x is greater than 0 but less than 1. Here we're going to have 1 and 5. And here we're going to have 5 and positive infinity. Okay, so these are our 3 intervals we want to test. And to test these intervals, what I'm going to do here is I'm going to create a table of intervals. So if I'm creating a table of intervals, what I'm going to do here is I'm going to place my intervals up top. Whoops. Okay, so you tend to use a ruler for this. 0 and 1, 1 and 5, and 5 and positive infinity. And I'm going to put my factors here, right? So this is 1 minus x, this is x minus 5, and then this is 1 over x. Okay. And let's call this guy our function r of x, right? Well, in this case, we'll call it what we called it initially. We'll call this AP of x. Okay, this is the average profit function. Okay, and we want to figure out when average profit is greater than 0. So let's test some values. So x between 0 and 1, let's say x is 0.5, which is basically, because x is going to be 1,000 units, it's going to be 500 units. Anyways, if we plug in 0.5 here, this is positive. 1 minus 0.5 is positive. 0.5 minus 5 is negative. 1 over 0.5 is positive, excuse me. And then you have positive times positive, that's negative. This is going to be less than 0, so this is where the average profit is less than 0. Let's say x is equal to 3 within the interval 1 and 5. 1 minus 3 is negative, 3 minus 5 is negative, 1 over 3 is positive, so this is positive. So this is where the average profit is greater than 0. And from 5 to positive infinity, let's say x is equal to 7. We get 1 minus 7, which is negative 6, negative. 7 minus 5, positive. 1 over 7, positive. And this is negative. So the only interval where the average profit is positive is between 1 and 5, right? So therefore, in 1 and 5, remember that x is in 1,000. Okay, so it's in thousands. So therefore, the production of snowboards between 1,000 and 5,000 will allow an average profit to be greater than 0, right? So it has to be, so it can't be inclusive of 1,000, 5,000. It has to be x belongs to 1,000 to 5,000 snowboards, right? So they're non-inclusive. So this is the idea, basically. So it's really interesting how we can use intervals, the interval inequalities of rational functions to model certain application questions.